Okay, hi everybody. In this video, what we're going to do is talk about running an OLS regression in Python. So let's look at the sample data set. We've got Coca-Cola, Pepsi, right? Coca-Cola in time t, Coca-Cola time t minus 1, Coca-Cola time t minus 2, dot, 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 and Pepsi in time t, Pepsi in time t minus 1, Pepsi in time t minus 2, okay? And then we have our returns, right? This is our return in period t, this is our return period t minus 1 for Coca-Cola, this is our return for Pepsi in period t, this is our return for Pepsi in period t minus 1. So this would be like 2.5% return. This would be a minus 1% return. This would be a 3.5% return for Coke. This would be a 4.7% return for Coke in period t minus 1. Okay, and let's say that these returns are all, let's say, the day after the earnings announcement, right? Earnings announcement for Coke in period t, the earnings announcement for Coke in period t minus 1, earnings announcement for Pepsi in period t, earnings announcement for Pepsi in period t minus 1. Okay, and so this is basically the day after they release earnings, let's say after the market closes and they beat by 1%, right? So then what is the return? It's 3.5%. So a 1% earnings surprise for Coke gets you a 3.5% return for Coca-Cola in this period. All right, so let's just quickly remind ourselves, what is an earnings surprise, right? So for these big companies, they have large analysts followings, right? There are a lot of analysts from the major sell-side investment banks that are basically trying to forecast what the earnings will be, right? And so they come up with a consensus. And let's say the earnings will be for Coke, let's say it's $2 billion a quarter, right? But instead of $2 billion, Coke comes out and says it's 2.2 billion, right? So analysts said it would be 2 billion. It comes out as 2.2 billion. So that would be a 10% earnings surprise, right? And then so if we wanted a 1% earnings surprise, it would be 2.02 billion, right? Um, and so that would be a 1% earning surprise um, for Coke, which would be about $20 million, right? So if Coke beats their earnings by 20, analysts forecast 2 billion, they beat it by 20 million. That's a 1% surprise. And then the question is, what's the return following that surprise? And it's 3.5%. Okay, so that's just one period. But then let's say we want to know overall, like what is the how does the returns correlate with earnings surprises? If you beat or if you miss. Okay. And so what we do here, and this is not joining two tables, but this is running a regression. Okay, so we want to run an OLS regression. And so this title should read running an OLS regression in Python. Okay. And then so specifically we say we run this return. We first, what we do is we say, okay, we're going to have a table, and it's going to be equal to OLS, that's ordinary least squares, and then return. So this is the return variable on earnings surprise, right? So we're regressing this return data, this return column on earnings surprise data. Okay, and then what data are we regressing it from? We're regressing it from Chris CompuStat 2019 through 2022, right? Um, and okay, and then dot fit. So this is basically where the regression is done. Then what we say, okay, we want to see the summary results of the regression, right? So we do basically 3-day return model table 2 equals summary equals 3-day return model table 2 dot summary, right? So we're writing out the summary results of the regression into this variable 3-day return model 2 underscore summary. And then in the final line of code, we say print 3-day return model table 2 underscore summary, right? So we want to print it out so we can see the regression results. And the above code allows you to run regression in Python. So let's see what it looks like. So the output of the OLS regression is as follows. We have the dependent variable, which is the return, right? So that's on the left-hand side, the Y variable return equals a constant, right? Which is negative 2%. And then the earnings surprise, the coefficient on the earnings surprise is negative 0.7%. So that means that basically for uh, um, when earnings surprises go up, the returns go down, right? And is that surprising? Yes, it is, right? Because typically we would expect that like a positive earnings surprise would be associated with a positive return, right? And so we would expect this number should probably be positive. Um, and then similarly for the constant, what would we expect the constant to be? again, I think in this case, the constant should probably be positive because, like, in general, what are the returns, like excluding beat or miss, in general, what are the returns following a earnings announcement? Probably they're on average positive, right? So setting aside what the earnings price is, it's probably true that on average it's positive. So this we would expect this coefficient to be positive and this coefficient to be positive. And so we would then so it's like, okay, well, it should be positive. Why is it negative? Well, maybe we didn't use enough data. Maybe like Coca-Cola and Pepsi, is not just these two companies over these 4 periods, is not enough data, and it's not representative of the full sample. So what we would do is then we go back and get the full sample of companies, not just Coke and Pepsi, but like thousands of companies over, dozens of quarters, run the regression, and it'll likely be a positive association. So this would be a positive coefficient. This would be a positive coefficient. So this T stat is the relationship statistically significant? And the answer is no, right? If the T stat is less than 1.96, um, then it's not statistically significant. So you can see both of these are not. And similarly, like the p-value is 0.47, 0.61, you can see it's not statistically significant. For these to be statistically significant, in one way, it would have to be like 0.05 or less, and this is 0.47. So this is far from statistically significant. Why? Well, we've got our number of observations up here, which is 10, right? So because I took the first 10 rows when running the regression, and so as a result, this is not enough observations to really give us statistical significance. Now, what about the R squared? What does R squared mean of 3.3%? R squared is basically to what extent does earnings surprise data predict or help explain the variance of the returns? So, like, if we know the earnings surprise data, what percentage of the variance in the return can we explain? That's what R squared means, and this is 3.3%. And so, do we think that's big or small? In my view, I think that's a little small, right? Because like the day after a return, or the day after earnings are released, or the 3 days after earnings are released, you would imagine that much of the stock price would be driven by that like huge news announcement that just happened. But another thing we can look at is, well, this we just took the actual returns and we didn't take the returns minus the market return, which would be like the idiosyncratic return for the company, if that makes any sense. So like we took the whole return and we didn't subtract off the market. And so part of the reason is like if there's other things going on in the market that day or those over those couple of days other than the earnings announcement, that can also drive the company's returns, right? And so if we wanted to increase this R squared, one thing we might do is go back to our returns, subtract off the market returns, right? And then that leaves us with just the return that's specific to Coke, or just the return that's specific to Pepsi, right? Because we take out the market component of the return, and then that might get us a higher R squared. Um, anyway, so I hope that this was helpful. This is how to run a basic regression in a basic OLS regression in Python, and I'll see you guys in the next video. And if you have any questions, feel free to post them in the comments, or any questions in the comments. Thank you so much.